Let's look at reflections. There are some rules for reflections that you're welcome to memorize and use, such as reflecting in the x-axis. If you are reflecting in the x-axis, the sign of your y value will change. When we write the rules like this, the negative sign indicates a sign change. It does not mean that your y value is going to be negative necessarily, and it doesn't mean that your x is going to be positive. It's just whatever you had at the beginning, you're going to change the sign on the y, and that is how you reflect in the x-axis. I personally like to graph and just count. If I'm reflecting in the x-axis, however far I am above it, that's how far I will go below it for the new one. And if I was below the x-axis, I would reflect to being above it. For the y-axis reflection, this is just a change in the sign of the x value. If my point was on the left and I reflect in the y-axis, I'll end up on the right. And if I was on the right, I'll end up on the left, and I will be the same distance from that y-axis. And so you can count on a graph to do this. When you're reflecting in the line y equals x, remember that the line y equals x has a y-intercept of 0 and a slope of 1. You would graph that line. If you want to use the rule for it, the rule is that your x and y change spots. They just switch places. That's your new point. I like to use the graph, and I like to count on the graph, and I'm going to demonstrate how I do that on the notes here. The line y equals negative x would have a y-intercept of 0, 0, and have a slope of -1. You would graph that on the graph grid, and you can use counting to graph the new points. Or you can use the rule where the x and y switch places and change signs. I struggle to memorize these rules because I know that I have to know the rules by heart for rotations, and you're going to have to know the rotations rule from memory. But if you are able to memorize your reflection rules, then that could help you as well. I personally just like to use the graph and counting. Over here, we're going to be reflecting in the line y equals x. So again, to graph the line y equals x, remember that the slope is 1 because it's like 1x. And the y-intercept, which is usually added after the slope there, is 0. And since it's 0, they just don't put anything for that in the equation. So we're going through the point 0, 0 with a slope of 1. Y equals x is a positive slope, sloping to the right and up. And then there we go. So this is our line of y equals x. And if you're graphing a reflection in a line, you must be the same distance on the opposite side of the line. And distance, we have defined distance from a point to a line as a perpendicular segment to that line. So what I need to do is I need to count in a perpendicular direction to this line. So since this line has a +1 slope, I need to count with a -1 slope. I like to just say I'm just counting diagonals. So A is 1 diagonal, 2 diagonal, 3 diagonal, and a half. So I have to go the same direction. These are perpendicular lines with each other. I have to go the same distance on the other side. So since I had a half here, I'm going to start with a half. This was 3.5, so 1/2. 1, 2, 3 makes 3.5 total. Here's A prime. If you'd like to compare the point coordinates, this was at -5, 2, and the new one is at 2, -5. Notice that they just switch places. When you're reflecting in y equals x, they just switch places. Reflecting point C, 1, 2.5 diagonals, a half, 1, 2. There is C prime. And point B, 1, 2, 3, 4. 1, 2, 3, 4. There is point B prime. In class, I will show you patty paper. Patty paper is tracing paper that you can use if you are wanting to check your work. You could copy, it's a tracing paper. You would trace the two figures, and you would trace the line of reflection, and you would fold the patty paper on the line of reflection, And if you did this reflection properly, all of your original points and all of your new points will be overlapping when you fold it on that line of reflection. And so it's a really cool way to check your work to make sure that you had drawn your diagonals the right way, or like if you use the rule, you can check that you use the rule properly for your reflection. I think those are the only two reflections we have samples of. So that's how you are going to be applying reflections. Oh, I didn't do sample 2, duh. So we are going to be having you reflect in other things like the x-axis, the y-axis, but also lines such as y equals to a number or x equals to a number. And if you graph these incorrectly, it's going to cause the problem to be wrong. Remember that y equals to a number is a horizontal line that goes through the y-axis at the y value they told you. And then x equals a number is a vertical line, and it goes through the x-axis at the number that they are giving you. So they have an equation here, x equals -1. Well, x equals a number is vertical, so I am going to have a vertical line at the x value of -1. So here's the x value of -1. I will have a vertical line in the graph at that in that spot, in that x value. So the distance that I'm going to be using here is currently I'm on the left of this line. I will go on to the right of this line, and I'm going to be the same distance away. So again, it's a perpendicular segment. 1, 2, we can see that is a perpendicular segment with that line. The distance is 2. So we're going to go 2 onto the other side, and then we have our new point. Be sure that you put your prime marking for your new point so we can tell the new from the old. If you don't put that, you might lose some partial credit there. That's a notation issue. This will be C prime. 1, 2, 3, 4, 1, 2, 3, 4 gives us A prime over here. So we have our triangle, our ABC there, and our original one and our new one. And if this was a quiz or something, we would probably have you list the coordinates. To practice that, C here is at 1, 2, A is at 3, 2, and B is at 1, 5. And reflections are some of my favorite ones. I always need graph paper for that. And if you have a question and they did not give you graph paper and you want some graph paper, just ask and I will get you some graph paper to help you out.